Hello. So we're going to try another problem from College Physics 2 that involve from Chapter 6. You can see here that involves capacitors in circuits. This example in particular involves capacitors in parallel, which actually it's the easier of the bunch. But we're also going to do other things with it as well. Try to find how much charge is on it and how much charging the total in the total circuit as well. What we are not going to do is D. We're not going to do that one, so I'm going to cross that out. Okay. So let's see what we're given. So first of all we're given the circuit in itself. Let's adjust a little bit. Okay. So we're given the diagram here, and all the capacitors are in parallel. Take note that the branch is breaking into 4 different parts, so this current or the charge is split, but the potential difference is actually going to be the same. Okay? So I think that pretty much is the given right there. Can't get any more simpler than that. So what are we looking for? Goals. We're looking for the equivalent capacitance, naturally, trying to find the total of, like, pretty much how does this work as one big capacitor or one single capacitor. And then find the charge on the 12, let's call it the 12 capacitor, 12 microfarad. And then find the total charge. Okay, and we'll stop right there. Now, formulas that we'll need. For capacitors in series, parallel, it's just simply straightforward. Just C1 plus C2 plus C3 plus C4, and that's it. And then we'll need the definition of capacitance. And boom, these are the only things that we will need. Okay, so adding up the capacitors is easy. Just literally adding that up. 3.0, 6.0, 12.0, keeping everything in 3 sig figs here, huh? And all of that is in microfarads, so answer should also be in microfarads times 10 to the negative 6. So that's going to give you 45 microfarads is the equivalent capacitance. So naturally it would work as a bigger capacitor. Okay? It's a microfarad. So now that we know that, and that our given, I guess I missed one given. There it is. Delta V is 18 volts across the entire circuit. So the charge on the 12 is just simply the capacitance of the 12, so I just write it out. 12 microfarad times 18.0 volts. Okay? And actually I'm just going to carry the microfarad. The units for charge should be in coulomb. Oops. Okay, and you actually get 216 microcoulomb. Okay? So the micro still pretty much carries on, and then there's a unit of charge. But how about for the total? Now, since we have the total charge will just be from the equivalent, our total capacitance, times the potential difference applied by the battery right there. And so that is actually not too bad either. That's simply the 45, not 4.5 microfarad, and we'll just carry on the micro as well, times to 18 volts, and we're going to get it's 810 microcoulombs, but the answer, if we keep it in 3 significant figures, would be 8.10 because it has 3 significant figures. Okay? Now I'm actually going to go and carry on to the other one. How about for capacitors in series? Now this is going to be the exact same amount of capacitor, but now all in series. So here the current is the same, or the charge flowing here is the same, but the potential it stops here, and then it moves here, and it moves here, and it moves here. So the potential is actually the sum of its parts, and it's going to be different for each one. And it still have the 18 volts battery, so that is the same, but it's going to give us different numbers. As you'll see, the capacitance, because for capacitors in series, the formula is, well, for this particular one, is the reciprocal, the reciprocal of the sum of the reciprocals. Try saying that out 10 times. 3 and 4. Now, what you can do, CQ, is you can do 1/3 and just solve it individually and just add it up in your calculator, then find the inverse of that, if that makes things any easier. Actually, these are, I think, all in 2 significant figures. Okay, so just add that all up. So this is going to be 0.33. It's going to be 0.17. I'm doing actually this one by one. 0.83 plus even smaller. Yeah, I could have predicted that one. 4.2, and the units here are actually 1/microfarad. Okay, add all of that up, and then you're going to get, so let's add that up, point. Okay, and then boom, doing it step by step. And then to get the reciprocal of that will give you an equivalent capacitance of 1.6 microfarad. Now what you'll notice from capacitors in series versus capacitors in parallel is that this has indeed made the capacitance way smaller. Okay, but for whatever reasons you want the circuit to be like that, that does happen. And then now we're going to still compute the charge on the 12 capacitor, and then find how much voltage drops across the 12 microfarad capacitor. Okay, a little bit different, but not too bad. So the charge on the 12 is still C delta V. Okay. And the charge there is actually the charge for the entire. So this is actually the charge total. So we can just use the equivalent capacitance times the 18 volts. So that's going to be 1.6 microfarads times the 18 volts should give us two significant figures. And once again, we're going to keep the micro, and we end up with 29 microcoulombs. Okay, now what do we notice about the charge here? Compared to what we had earlier, this one is actually also, if the capacitance is smaller, then this is also less as well. Okay, how about the potential drop? This should be different. So the potential drop across the 12 should be the capacitance on the bottom rather. Okay, but this is actually the equivalent, the total charge. And so that's going to be 29 microcoulomb divided by 12 microfarad. So honestly, the micros cancel out. And you're going to end up with 2.4 volts. And sure enough, this is definitely less than the 18 volts. Okay, because the volts here plus the volts there plus the potential drop there, 3, should equal the entire potential difference, which is the 18. Okay? And there we go. That is it. Take note the differences between capacitors in series and capacitors in parallel. What is the same and what is different? Okay? Hope you all understood that. Take care and enjoy. Good luck.